So if we look at the last few sessions, what did we do? I think we started with understanding of the business statistics. So that's the place we discussed about descriptive statistics and inferential statistics. And then we started with the predictive modeling, and we seen that the types of business problems. And when we look at the types of business problem, we also discussed about one type is regression, one type is classification, one type is segmentation, one type is forecasting. And of course, there is a set of techniques like optimization and others. Okay, so of course, we are not touching upon these two things as part of our course curriculum, but at least we discussed about regression, classification, segmentation, forecasting. And if you understand the regression, this is a predicting a value problems and predicting an event or predicting or classifying the data into predefined groups. Correct? Yes or no? And then classify the data into n number of groups based on similarity.
I forgot binocular.
Don't worry. N number of groups based on similarity. And forecasting, predicting a value over the time. Right? So this is the place we discussed about linear regression, and this is the place we used a GLM. Specific technique is logistic regression. And here primarily we look at the k-means cluster analysis, of course, and we also discussed about some heuristic approaches. And here we discussed about one is decomposition of time series and regression as a one approach, and the other approach is the family of ARIMA model. Of course, there is a ETS models. Of course, we did not explicitly talk about that, but I explained the concept of what is ETS models means. Correct? I think these are the set of things we covered. So if you look at all of these things, there are two types of objectives which we are trying to leverage. One objective is, okay, so when we are discussing about key things, identifying drivers. What is identifying drivers? For example, the sales is driven by certain parameters or certain variables. The sales is driven by certain variables. If you remember, we were discussing about very first problem of linear regression. There, what we are trying to do that? What we are trying to do. So if you remember the automobile case study, what did we do there? The car sales, of course, predicting a car sales. And there we also identifying the list of drivers which is a selling, which is driving sales, so that in my next product, you know, I mean creating a next product, I will make sure that these drivers will be taken care. A simple example is a price. The other example is a passenger vehicle, and other a regular vehicle, and the other.
So, ఇక్కడ బాక్స్ లో రాయాలి ఇక్కడ ఆప్షన్
Okay, cool. So the identifying drivers, what does that means? So is it a positive driver? Is it a negative driver? Positive driver, that means that it's driving. The one is increasing, the sales is increasing. The negative drivers means one is increasing, the sales is decreasing. Similarly, we also discussed about the classification problem where we did predicting a default, predicting a, what is that? Delinquent customers, the bad customers. There also we got the drivers. You remember? Logistic regression also we got the coefficients. If the coefficient is positive, it's a driving. It's that particular variable is driving the bads positively. And that is, if negative means it's a driving good. So that value is increasing. It is a negative value means it's a less bads, more goods. Correct? So indirectly what I'm saying is these linear models, especially logistic regression or linear regression or these things will also help me to get drivers along with the predicted values. Do you agree with me? And you can also quantify it. I mean, which driver is most important, which driver is less important, right? So this is really help you to understand the drivers. This also help you to quantify how much each driver is contributing. Am I correct? Because you remember, based on the t-value or based on the p-value, which we are saying that it's more significant or less significant, etc. Do you remember or not? So these are the techniques. You know, most of the time, this is help you to predict the values as well as predict the segment or predict an event, whatever it is, and identify the drivers to take a strategy. For example, you know, my price is contributing a maximum importance to maximum driving factor of a sales of a car. Then when I'm creating a new product, I will give a more importance. How can we reduce the price? Does that make sense? But if the price is not the thing, the fuel efficiency is the most important factor, I will try to give more importance to fuel efficiency. Correct? For example, customers are bad. Suppose a particular location is, you know, there are a lot of customers are coming from the particular location is bad customers. The majority of customers are bad customers from that particular location. Then what we will do, we will more scrutinize the applications when we are accepting for the credit card or maybe loan or whatever it is. So that way, what we are trying to do, we are strategizing things based on the factors which are more contributing, which are less contributing, etc. Is that correct? So defining the strategy, you know, this will help you to, I mean, these drivers will help you to define a strategy. Are you clear what I'm trying to say? So if you remember, in the very beginning stage, I was explaining that the types of business problems is one type of classification is this one. The other type of classification is strategy problems and operations problems. When I say strategy problems means, you know, the solution, whatever you are getting out of the predictive model can be one of the input to take a strategy or define a strategy. So like, for example, some problems you can't solve immediately. That will take some time to overcome. For example, you know, customers are churning. So customers are churning, you know, one of the key problem you identified is the sales, I mean, the service team. You know, customer service is the one of the key thing. You know, we observed that many people are not interested to continue with your company. For example, a telecom company is there and the customer service is very bad, or maybe the signal is very bad. I mean, the, you know, more majority of time the call drops, etc. happen. So if that is the business, I mean, that is the majority of people are feeling that, and that is the reason people are leaving. So will you able to fix the signal problem in a one single day? You can't do that, right? Probably it will take some time. And can you change the customer care service center in over the night? You can't do, right? So that takes some time. Probably, from the existing group, I need to train them properly, or maybe, from the existing, group, some of the, customer service agents are not doing good. So probably I will fire and I will hire the new guys. That takes some time, maybe a 3 months or 4 months or 5 months, to come up with the proper customer service team, right? So that is the kind of situations, these are the some of the inputs will be really helpful. What are the inputs? My customer service is one of the key factor for a customer attrition. Then I will, next 6 months time period, I will try to how to make or how to improve my customer service. I will define a strategy for that. Is it clear? So that's the kind of scenario. The strategy problems is a problem which we will solve over the period of time to improve the business goals. So a lot of times the business problem, you will know that, but that problem we will solve over the time. So that is the strategy problems. And what about operations problems? The operations problem is something you need to take a decision. You need to take a decision. I mean, when I say you, I mean to say that you are representing a company. That means, I mean, as an analyst, suppose if I'm working for a Tata Group, as a Tata Group, I'm representing, for example. Then you are representing the Tata Group. So that means that you need to take a decision very quickly. A simple example, I was mentioning that the decision process, something like a customer is visiting your website, I need to immediately recommend the products. How much time a customer will be there? Probably first few seconds, you need to really identify what type of behavior of a customer. Do you agree with me? And in that case, will you get time to think and strategize what products I need to offer to the customer? Right? I need to come up with some kind of a product, some kind of an engine. That engine should automatically recommend the product. So that means the manual intervention should be very less. If the manual intervention is there, then the time consuming will be more, because the time you cannot take a decision in a fraction of seconds. And the other example I was giving, that suppose a transaction happened through your credit card. Is that transaction is genuine or is it a fraud? Will you get time to think and give the this transaction is genuine and fraud or not? You need to take a decision very quickly. You need to take a decision in a fraction of seconds. That means the system has to take a decision. And that's the kind of scenario, the accuracy is extremely important. Accuracy is extremely important. And there, I don't mind what kind of model I'm using, what kind of a mathematical equation I'm using, whether it's driving positively, whether it's driving negatively. I don't really care about. What I'm caring about? I'm caring about the accuracy, how accurately you are predicting it. Am I correct or not? So this is what the operations, problems. The operations problems is something we will take a quick decision. So that means that quick turnaround time.
Yeah, you're writing ball.
Okay, so quick turnaround time. And the second thing, high accurate with the minimal intervention. Correct or not? So these are the few important characteristics of operations problem while you're solving it. So this is the place, whatever the existing models which I was explained till date. So there my focus will be how good or how accurately something is not the thing. My focus is more on the, okay, whether I am able to get a solution, is the solution is able to help me to take some kind of a decision, but it's not necessary that quick decision. So you got a model, but that model may not be as good as high accurate model, right? So the strategy problems perspective, whatever I was explaining, the like linear models, whatever the models which we are discussing till date, those are all are, helping you to explain the solving strategy problems. So where we are trying to give importance to explanatory, explainability of the model. And explainability of the model is my main purpose. Okay, when I'm looking at the model equation, I should be able to understand what is that equation is telling me, right? Here I will give more importance to high accuracy. I don't mind what model or how complex model it is. What I want, am I getting high accuracy or not? So this is the place we called a traditional approach. The traditional approach, whatever we discussed in the last few classes, that comes under traditional approach. The traditional approach, I mean to say that a person will decide what model is the best model. Here, the machine learning approach is followed. Here, a machine will decide a best model based on high accuracy model. Based on high accuracy. So now you understand what is I'm trying to achieve. What I'm trying to achieve is, so here the model is what? A traditional model, a traditional approach, where my approach is helping me in terms of the person will work on the model and he will decide what model is best. But in the machine learning approach, a machine will help you to get a best model based on the high accuracy. Of course, the commands will be provided by human only, but within the limitations of that commands, and it will identify a best model for you. So indirectly, what I'm trying to say is something like this. So if you remember, when we are working on ARIMA, there are two approaches we followed. One is we identify PDQ values and build the model. Correct or not? Suppose you remember last class 1, 2, 1 is the the PDQ values we identified, and using that PDQ you build the model and you forecasted the accuracies. And but the other approach, what did we do? We have taken a combination of values for PDQ, and the machine identified a best model by identifying the best combination of PDQ, which gives you a minimum AIC value. Do you remember or not? So this is an example of a traditional approach versus a machine learning approach. Are you able to follow me? So what did we do there? The methodology, everything is same. What I'm trying to do, instead of identifying my best model by iterating manually, what I'm doing, I created some kind of an algorithm which will help me to get a best model within the values of PDQ what you identify. So what we are trying to do there, we are doing a searching a best values for PDQ. For a PDQ, within the grid of values. What is the grid? Grid is a fixed number of values we given. How many models? Suppose you remember P equal to 0, 1, 2, D equal to 0, 1, 2, Q equal to 0, 1, 2. I think that is what we have taken the grid of values. So how many models are possible? So 3 into 3 into 3, 27, and 27 into 27, around 729 models. So basically what you got it, 729 models we got it. And out of these 29 models, one model has been finalized based on a low AIC value. This is correct or not? So that means that what did we do? We are building a factory of models and choosing a best model out of it. Choosing a best model out of it. So this is what exactly the machine learning approach is telling you. Right. So generally the first thing, what did we do? The first thing, we come up with the PDQ values and we run the model and we got the result. And again, we did the another model by changing the PDQ values and we got another model and we are comparing the results, and whichever results is giving low, and that's what we are doing a manual approach. And in this case, what is the approach? In this case, the approach is, you given the values of PDQ, you test it and give me the best combination of PDQ, which can give me my best model. So what is your input in this case? The input of the model. Of course, the data we given, and the input is the values of PDQ, and you got output, right? You got output, and this is the input and output. The output is basically what? The predicted values of a model. Basically, a model is nothing but what? The program. Of course, sorry, we given the program and then the model, you got it. Am I correct or not? So the data we given, the values of PDQ, once you give the PDQ, that is the program, right? That is the program, right? Based on the PDQ only, the Sarimax you applied and you got the best program for that. And in this case, what is your input? The input is of course data, and you given the grid of values, and you also given a metric to compare, the AIC or something you are asking, because based on what it will identify the best model. In this case, we given that AIC, and you can also give the BIC also, or maybe you can also give the MAP also, whichever is best. So then what is your output? You got it? The program with the PDQ. I mean, basically you got the values of PDQ, right? Because if you know the PDQ, that is nothing but what? The program, right? Am I correct or not? So this is a typical understanding of a traditional approach of the model versus a machine learning approach of the model. So what I'm trying to say is, in this case, my input is the data, and of course, you build the traditional approach, and you also give the program, and you will get the output. Correct? So this is my approach of okay. So in this case, what is your input? Of course, the input is data, and of course, this is a machine learning approach. And what is your approach of output? Program. And in this case, what is your model? Input is of course the output. The output is basically in this case the metric like, you know, are you able to follow me what I'm trying to say that? So now you understand what is the traditional approach versus what is the machine learning approach. So with this introduction, can you define what is a machine learning? With this introduction, can you define what is a machine learning? So in this case, what is learning? I mean, what is the machine is learning? The machine is learning based on the data, based on the output, and what we are trying to learn, identifying the best model. So that is what, within the data, it will identify patterns, whatever the relationships, whatever it is. End of the day, what you will get it? You will get a model with high accuracy. In a traditional approach, what we are trying to do? Okay, we are building a model based on the input and based on the program, you will get the output. That's all, output as a model. But it will not give me that, is it a high accuracy model or not? I don't know. Am I correct? So in this case, what is your control? What is there in your control? The control is the model, whatever you want, you can use it. I mean, whatever the program, you can write it based on the program only, you will get the model. And what is there in this, in your control in this? The control is the grid of values for a PDQ in this case. So this is what we call it as a tuning parameters. Tuning parameters. So that means if I tune the parameters, I will get a different model. That model can give you high accuracy. So that means that if I'm using a technique, for that technique, you should know what are the tuning parameters. What are the parameters? If I change it, I will get a different models. By changing the values of, for example, PDQ, by changing the value of PDQ, I will get a different models, right? Yes or no? Suppose P equal to 1, D equal to 1, Q equal to 1, I got one model. P equal to 2, D equal to 1, and Q equal to 1, I got another model. So these models are different, right? Correct or not? So that means that if I change the values of those tuning parameters, I will get a different models. So that is what I'm saying, that how to get a best tuning parameters is the key thing when I'm trying to work on a machine learning problem. So that means that for each technique, what are the things you should know? What are the things you should know? You should know the tuning parameters and what are the approximate values? Approximate values of tuning parameters. Suppose a tuning parameter values is between 1 and 10, but you given 100. Will it work? So that is what at least you should know, what is the approximate values. And the default values. Default values in the technique. So I mean to say that if I'm using some technique, if I don't specify those tuning parameter values, it will take by default values. Even if you remember, we created auto ARIMA function. If I don't supply the PDQ, what it will take the values? I think you remember 0 to 3 and 0 to 3, etc. And yesterday, you remember, while I'm creating a auto ARIMA function itself, there by default I specified the values of PDQ. Do you remember or not? So I think that is what I was referring over here. So indirectly what I'm saying is, in a machine learning approach, you should know how to get different models. When I say how to get different models, that means of course you can use different techniques, you will get a different models. That is one thing. And the second thing is, by changing the parameters of that model, you can also get a different models. So those parameters, we call it as tuning parameters. And by changing the tuning parameters, you will get the different models, so that you can choose a best model out of it, right? So that is the concept of tuning parameters. You know, in this case, I think still we did not answer the what is the machine learning definition. I think now you understand what is the high level conceptual understanding, but what is the machine learning based on this understanding? What is machine learning, guys? Okay, what is machine learning, guys? What is the definition of machine learning? So the machine learning, I think, I think if you understand the definition a little bit, what I discussed, the traditional versus this one, a machine learning is based on algorithms that can learn from data without relying on a rule-based programming. What does this mean? So in a traditional approach, like for example, heuristic segmentation, what did we do? What did we do? We come up with our rules. The rule says, okay, if it is a value-based segmentation, I'm saying the 10th percentile, 20th percentile, 30th percentile, etc. If any value is greater than, less than 10th percentile, I'm calling this a 1, segment 1. Between 10th percentile and 20th percentile, I'm calling this a segment 2. So that is nothing but that is a rule. Correct? But the same thing, if I apply using a k-means, is a k-means algorithm, if you think about it, in this case, what is the parameter, tuning parameter is there in the k-means cluster analysis? What is the tuning parameter? It's a k value, because for a different k values, you will get a different segments, and you need to identify a best segment. In our case, how did we identify best segment? Based on the Silhouette coefficient, based on the profiling, based on the distribution of the data, etc. Of course, I shown you manually in that. But if I want to automate that, how can we do that? Based on the Silhouette coefficient, whichever k is giving you maximum Silhouette coefficient, that will be your best segmentation. Do you agree with me or not? So that is how the segmentation itself. If you look at the k-means, can be considered as a machine learning technique to do the segmentation. If you assuming that the k is for a different case, you will get the different segments. Different segments mean have different segment solutions. Okay. Now, can you say that a linear regression? Can you say that linear regression is a machine learning technique or not? Of course, it's a machine learning technique, but you can also use it for a traditional approach. The technique is still be considered as a machine learning technique. But what is you are trying to achieve there? There the accuracy may not be as good as, because there the tuning parameters are not much. Only the learning rate is the tuning parameter, but that's not going to be helpful to improve the accuracy. So that's the reason a linear regression, logistic regression, and the generalized linear models, etc. we always consider as a traditional approach techniques. But if someone question on you, is an algorithm can be used as a machine learning approach? Yes, you can. Is it clear? Okay. So, and there is another definition of machine learning. So, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So, is that definition make sense based on our understanding? So, are we explicitly programming it in machine learning? So, what are we programming it? Okay, we are giving the grid of values and we are giving the function, and tell me, boss, use this technique, use the values of tuning parameters, give me the best parameter. When I say explicitly programmed means I'm asking for a given tuning parameters, given the values, give me the solution. That is the explicitly programmed. When I'm not giving explicitly programmed, that means I'm asking to look for the best solution out of possible solutions. Then that is what we call it as I'm asking machine to decide what is the best model. So that is this one. The machine learning is the field of study that gives computers to ability to learn without being explicitly programmed. When I say learning is nothing but what? Coming up with a model, estimating the betas. That is what the learning in our case. What do you mean learning? A learning is nothing but coming up with a predictive model, right? So if you remember yesterday, I supposed to get a best ARIMA model. What did we do? If I give a PDQ values on my own, I will also get a model, but that model may not be a best model. So what we are trying to do, I'm asking for different combinations of 728 models and asking that give me the best model out of it, right? So when I say the learning, that's what I want. A computer learns effectively if its performance on certain tasks improve the experience as measured by some performance metrics. So in our case, what is the performance metrics we compared in ARIMA? AIC value. Correct? If I take a segmentation, what is the performance metric I can take? Self-height coefficient. Am I correct or not? So the learning, whether there is an improvement in the learning, that is based on the performance metric, we will say that there is improvement in the learning. Do you agree with me? Good. So I think this is what I was, referring when I was talking about machine learning approach. So yeah. So the classical programming, I was referring that, okay, the input is the data and it will pass through program and the output you will get it. But when I given that machine learning program, output and the input I will supply and I will ask them to come up with a model, and that model will be finalized, and based on that you will get the predicted values. So this is the a difference which I was talking about. Does that make sense? Okay, so I think these are the foundational things which you need to understand. And the second important aspect which you need to understand, there is a concept called bias and variance. What is a bias and variance, guys? Okay, so let me explain this one. Okay, so let's take a simple example. Suppose there is a data, you have it. So this is the data, you have it. What is this data? Suppose assuming that X and Y, and the relationship is X and Y is what? Some kind of relationship like this. Suppose if I come up with a model like this, and if I come up with a model like this, and if I come up with a model, suppose like this, which model is better? This model is better, or this model is better, or this model is better? So this is my training data. This is the relationship, you have it. So what I'm saying is, if I come up with this and I come up with a simple linear model, okay, and this one is a non-linear model which is passing through every point of data, and the non-linear model which is not passing through every point but which is closer to the points. So out of all three, which one model is better? The first one, third one. So why third one? And this is the best fit, right? If there is no error, in this case, is there any error? Because for every value you are predicting exactly, right? In this case, is there any error?
With high variance means it leads to overfitting.
No. First of all, don't get into that. I'm asking what is the question. The question is, out of these three models, which model is best? First model, why?
It is neither overfitting or under.
I don't know about overfitting and underfitting. Tell me, out of these things, what is the logic you are using by looking at them, and which model is better? I don't know about any terminology. Okay, tell me out of these three. Okay, first of all, when we are deciding the model, on what basis we decide the model? Okay, first is high accuracy. And the second thing is what? That is nothing but accuracy, right? What is the other one? What is the other one? What do you mean low variance? So when we are looking at the accuracy, I'm not just looking at my accuracy at a training data. I'm looking at the accuracy on the testing data. Which model will give me highest accuracy on my test data? Okay, so that means that the model should be validated. Okay, the model, I mean, how to choose a best model? Okay, so let me explain that. That is most important thing. How to choose a best model. So one is, of course, model should give high test accuracy and model should validate on the test data. That means that you should not have a very high compared with the your training. At the same time, low also should not be. So it should be similar to that. And the third one is it a explainable or not explainable? That is a different story. That is at this point of time, I'm not worrying about that. So explainable is nothing but depends on the technique. So for example, if some techniques, will give you high explainability of the model, some techniques which you can't really explain what is that output equation or what is the underlying theory of it. So at least these are the two cases I look at. One is my model should get a high test accuracy, and my model should be able to validate on my test data. Correct? If you can assuming that those two, now tell me what is the best model. So if I take this, if I take the first model, suppose if I'm taking a linear equation like this, of course. So assuming that this is a linear line, of course it's not. Okay, but if I take a linear line, so is this errors are more or not compared to this or this? When I say errors are more, the training accuracy itself is low. The training accuracy itself is a low. And what about this? Of course, the training accuracy is low. Sorry, training accuracy is high, but do you think testing accuracy will get similar kind of high accuracy? Because for example, if this is the model equation, suppose a new value is coming like this. So is this value is coming this side or this side or this side? How will you know is this line equation will go this side or this side, etc.? It's a really highly unpredictable. So that means that on the test data, you can't expect similar kind of a accuracy. So if a test data is not getting similar kind of accuracy, what is that problem means? Overfitting problem. And if the data itself is getting a low accuracy, what is that problem? It's underfitting, because there is a possibility of getting the model, with the 70% accuracy, but the technique is giving only 50% accuracy. That is nothing but underfitting. Overfitting is nothing but you got very good training model, but at the time of testing, you are not getting a similar results. So that means that this is, if I take a linear line, there is a high possibility that that line equation may not give you the high accuracy. So that means that can lead to underfitting. And this is you have a high training accuracy, but there is a high possibility that the testing accuracy can be low. So that means that this particular thing will lead to overfitting. And of course, this one, there is not many fluctuations, and the accuracy compared to this one will be high in training as well as a testing. Training as well as a testing. So that's the kind of scenario. Probably this can be a better fit compared to a linear line, or compared to this kind of a nonlinear equation. Of course, this is also nonlinear equation, but in this case, the fluctuations of the line, is very minimal, so that you can predict little better. But here you can't predict what is the next movement of the line. So that's the kind of scenario where you see a lot of fluctuations in the data. I mean, fluctuations in the data means, the line. And that is, we call it as a high variance. So the variability in the line is, we call it as a high variance. So in this case, this one have a high variance, this is a medium variance, this is a low variance. Because if one single linear line, is it any kind of fluctuations in that? There is no fluctuations. So that is the what exactly we call it as a low variance. There is no fluctuations. High fluctuations means high variance. And the bias means the error, the training error. In this case, the training error is high or not? Yes. And this one is medium, this one is low. So this is what we call it as a low bias and high variance model. Low bias and high variance model. And this one, of course, medium bias, of course, this is wrong. The medium bias and medium variance. And what about this one? High bias, low variance model. Correct? So which model is better? Medium bias and medium variance. So ideally, you should get a model with a low variance and low bias model. With low variance and a low bias model. But that may not be possible, because if I have high variance, getting a low bias model is possible, but that may not give you the test accuracy. So that's the place, if your model have high variance, that can lead to overfitting, and if the data have a lot of bias, and that can lead to the underfitting. So what is our objective? Our objective is, you need to manage the overfitting problem as well as underfitting problem. That means that you should get a model with a low bias and low variance. So that may not be possible. That's the place, by increasing a little bit bias, and you should able to decrease the error problem. So, but what I'm trying to say is, end of the day, I try to take the trade-off between bias and variance. So let me show you the example. If you look at this one, so what is this tells me that, if you look at, this is my model complexity is increasing, and that is nothing but, when I say model complexity increasing, nothing but high variance. The x-axis think about high variance, and y-axis think about high bias. The error is high. So that means that if the bias is high, obviously the variance will be low. That is, I already told you. So, but you cannot get high bias model, because high bias will leads to what? Underfitting problem. And if I increase the high variance, what is the problem? Overfitting problem will come. So basically, if I look at this one, of course, my line equation something like this. So basically, what happened is, if I look at the model high bias and high variance, so what I was referring is, if I take high bias, so if I look at my the error, training error is something like this. So the training error, something like this, it will reduce, and testing error, it will be like this. Of course, after that it will increase actually. So basically what I'm trying to say is, if I increase my variance, there is a problem of overfitting. Okay, and if I increase the high bias, there is a problem of low accuracy. So basically we will try to, where I'm getting the a model with a similar kind of a training error, training accuracy and testing accuracy. So that is the kind of situations you need to come up with a medium variance and a medium bias. So that is the kind of a thing which we are trying to achieve. So basically, if you look at this one, the underfitting problem is, how can we overcome? So end of the day, what I'm saying is the objective of machine learning. A machine learning model, machine learning approach to get a model with low variance and low bias. Low variance and low bias. So generally that is not possible. If completely low bias and in a completely low variance, that's not possible. So that's the place we need to take a trade-off. So indirectly what I'm saying is the model, the objective of the machine learning approach is to get a model without overfitting and underfitting. Wait, I will give you underfitting problem. Are you able to follow me? So a model should not have a overfitting problem. A model should not have a underfitting problem. So now this is the place I was talking about, the overfitting problem. How can we overcome? And underfitting problem. How can we overcome? So underfitting problem we can overcome by taking the grid search. Because end of the day, what I want to get a model should get a high accuracy. So this is what the high accuracy thing which you are taking care. And a overfitting problem, that means that the model is giving high accuracy in a training data, but not giving a high accuracy on the testing data. So this is the case we will try to perform a k-fold validation or a cross validation. This is one approach. The other approach is, one is a k-fold validation, the other one is regularization. So basically high variance is giving this problem and high bias giving this problem. So basically high bias underfitting problem that can be overcome to get the best tuning parameters, so that will give you highest accuracy. And a high variance will give you the overfitting problem. To overcome that issue, we will take care of cross validation and regularization. Is it clear? So basically whenever I am referring to the machine learning, these are the key concepts which we should know. If you know about this one, that's all. Everything, the entire process will be remaining same. You understand what is the concept of high bias and high variance and what we are trying to achieve? And why we are taking care of the high variance problem? Because that's leading to the overfitting problem. And why we are worrying about high bias? That leads to the underfitting problem. So to come up with a best model, that means that you should not have underfitting problem, you should not have a overfitting problem. So to come up with that best model, we have a certain things which I was mentioning, that the grid search concept will help me to get a best model by tuning the parameters. And there is another concept like k-fold validation and regularization. I will explain you about what are these means, and those will help you to handle the overfitting problem. Yes. High variation, I mean, it is not standard deviation. High variance I was referring in this case is the model with a lot of flux. I mean, the model equation is not a straight line. It's like having a model equation is non-linear in nature, but with a lot of fluctuations. that is not an error, right? No, that is not an error. That is, it is passing through every point. That means it's high variance. If the data is not having a linear relationship, if the data is having a non-linear relationship, and if you're coming up with a non-linear model which is passing through maximum points out of it, and that may lead to a overfitting problem because it has a high variance. So that's what I was referring that. If I come up with the model like this, in this case, what? It has a lot of fluctuations. And what about this one? This is also a non-linear model, but this has a less number of fluctuations. You can, predict the test, I mean, the new data, which will give you a similar kind of accuracy. Does that make sense? Training data. Is this clear? The meaning of this one. And the other one is, I will explain what is a k-fold validation, etc. The other important thing is metrics. I think you guys remember regression related metrics, classification related metrics, segmentation related metrics, forecasting related metrics. Yes or no? So those metrics is something which we will use to compare the models. Which model is best or which model is not best? How will you check it? Based on the metrics, right? So those are very important. I think whatever the metrics we discussed in the past, the same set of metrics will be used. There is no difference. All metrics will be the same. And the process of, in terms of data preparation, again, it's same. There is no difference in the process of steps. Only difference which you're seeing is, instead of using model selecting manually, we are automating things. What is automation? The machine will decide the best model for you. That's all. By changing what is control in your hand is changing the parameters. Giving the grid. That is the only thing you have in your control. And the machine will automatically decide the best model out of all possible things. That is what the tuning parameters or tuning hyperparameters, all of them are same. So this is what I was talking about. Tuning the parameters only we call it as a hyperparameters. I am talking about the machine learning. In the machine learning perspective, why you called the deep learning concept here? The concept of tuning parameters, this is nothing but tuning hyperparameters. That's all. Even deep learning also is a subset of a machine learning. So if you say that deep learning, don't get confused. It's a subset of machine learning. There are a set of algorithms which is extension of a neural networks. That's all. Which is an extension of neural networks. There is no difference as such. Make sense? Any questions? So till now, any questions, guys? Okay. So let me explain what is this cross validation. So generally, when we are doing the validation, how did we do that? How do we do validation of model? So we split the data into train and test, and validate the model. Build the model on train and validate the model on test. So this is the typical process which we follow, correct? But that means that by the time you are validating model, you are already deciding the best model, right? Of course, It may not be a best model, but still you're almost finalizing the model based on the training data. Correct? So, but what I'm trying to say, before doing the validation, I want to make sure that my model should be validated. At least I should get some kind of a confidence my model is validated. So that means that machine itself should take a best model which will give you high accuracy and which should also works on a new data. Does that make sense what I'm trying to say? When a machine is deciding, of course, it should get a high accuracy. That is no doubt at all, because by tuning the parameters, you will get the model. But at the same time, that whatever the model it's chosen, if it is not working on the validation data, that may not work. That, I mean, whatever the tuning parameters you got it may not be helpful. Correct or not? So that is the reason what it is doing is, while I'm building the model itself, I am getting a model which works.
Going to play pineapple.
Go. So what I'm trying to say is a model which gives you high accuracy, and it should also works on new data. So the first criteria is high accuracy. The second criteria is should work on new data. Sorry guys. Okay, so now you understand what I mean to say that. So this is the place, what I'm saying is, while I'm building a model, I'm validating model on new data. So how can I do that? This is the place, you know, we do the cross validation concept. What does that mean? So out of cross validation concept, one of the popularly known technique is what? K-fold validation. So what is a K-fold validation? A K-fold validation is nothing but, suppose you have 1000 observations and you split the data into train and test. So 700 observations and 300 observations. So this is my train data and this is my test data. Or just simplification perspective, I'm keeping as a 800 and 200. Okay. Now, if I'm taking a K-fold validation, I mean to say that K equal, suppose I'm taking as a 5. K equal to 5. So what it will do is, this 800 observations will split into 5 equal parts. Okay. So what is the, 5 equal parts means parts. So the part 1, 200 observation, part 2 is 200 observations, sorry, not 200, 180 observations, so sorry, 160 observations, 160, 160, 160, 160. Okay, so these are number of observations in each part. Okay, so this is a N. Now what it will do is, when you are performing a K-fold validation, it will build 5 models. How it will build? M1, M2, M3, M4, M5. So these are my 5 models. When you are building a 5 models, the model will take train and test. So that means that out of this 5 parts, it will take 4 parts. Okay, part 1, part 2, part 3, part 4, or maybe 2, 3, 4, 5. It is taking as this is a train data. My test data is part 1. And 1, 3, 4, 5, and 2 is my test data. And 1, 2, 4, 5, and 3 is my test data. 1, 2, 3, 5. My 4 is the test data. 1, 2, 3, 4, and 5 is my test data. So like this, can I build 5 models? So I'm doing a 5 models like this, and I can calculate the test accuracy. Okay, I got 80% here, 82% here, 83%, 81% here, 75% here, 74% here, for example.
Mama, 30 days.
Okay, so now which one is the best model? So how can we say it's the best model? Because it's validating on a new data which is giving a high accuracy, right? So can I say that this model will be a best model? Okay, this model M2 will be chosen as a best model, and M2 will run on all the data. All the data means all the 800 observations. Correct? So that means the tuning parameters will be decided, of course, not tuning parameters. I mean to say that the model will be decided based on the high test accuracy, and that will run on the all the 800 complete trained data. So that is what you are calling as a cross validation. That is what we call it as a cross validation. So the cross validation, I mean to say that in this case, what I'm trying to do, I'm getting a model with high test accuracy. That means that the WAR, I mean, you can reduce the problem of WAR fitting while I'm building the model itself. So once I get the model, of course, I can test it on my test data also, and I'm getting a similar accuracies of training and testing. But before doing the testing, I'm doing a 5 tests. What iteration? Though this is nothing but I'm deciding that k-fold validation is how many times I want to validate. Is it if it is a k equal to 5, this will be decided as a 5 times. If it is a k equal to 10, it's a decided the 10 times. So the k will be changing. So if the k is doing 5, that means it will divide the data into 5 pods and it will build the 5 models. If it is a k equal to 10, it will divide the data into 10 pods and it will build the model on 10 times. Right? So now you understand what is the cross validation means. So now, for example, if I'm giving a k equal to 5, suppose assuming a simple example is k equal to 5, and my PDQ is, of course, some tuning parameter you have. Okay, parameter 1, parameter 2. So parameter 1, you have a 5 grid values, and here 5 grid values you given. And how many models are possible? 5 into 5, because this combination is 25. Into each model will, how many times it will do that process? 5 times. So that means 125 models will build. Are you able to follow me? So that is the idea behind the k-fold validation and grid sets. The grid set is helping me to get the high accuracy. My k-fold validation will get me high testing accuracy. So that means that my grid search will help me to get a low bias. My cross validation will help me to get a low variance. Then again, you need to rebuild the model. I think that is what exactly we are trying to understand. So when you are getting a your testing accuracy is not coming as your training, that is nothing but WAR fitting problem. That WAR fitting problem, why you are getting, more probably there are possible reasons. I explained that also. What is the possible reasons I was explaining in the WAR fitting problem, guys? Possible reasons for WAR fitting problem. It's because of high variance. But high variance, why you will get it? More number of variables. More number of variables are, of course, that is nothing but the high variance. More number of variables are more transformations. These are the 2 reasons you get a high variance model. Correct? And the second reason is low data. Less amount of data. While you're building a model itself, you are not having too much data. So that itself. And the technique, even technique also sometimes matter, because I told you, and if it is a linear regression, there is a less problem of low, it's a low variance technique. But the problem is what? High bias, right? Okay, so are you clear now? What is it means? So these are the possible reasons, guys. So when I'm getting my overfitting problem, either you need to take care of less number of variables or less number of transformations, or increase the data size, or change the technique. I think these are the things which I was explaining in one of the class. You guys remember or not? Correct or not? So now you understand the concept of the cross validation. What I mean? Okay, the regularization is something, the cross validation is what we are trying to do. We are trying to get a best model out of it. The regularization is something we will adjust betas. We'll adjust betas. That means we'll correct betas such that high, high influence, high values of beta will increase the beta value. High values of beta, variables with high values, variables with high beta values will get more significance, and variables with less beta values will get less significance. So what does that mean? A variable is high significant. When can you say that a high significant? A beta value is high. If the beta value is high, we are trying to increase the beta value so that it will be more important. And if beta value is low, that means less significant. But because of you are using a 95% significant, etc., it is a close to border. And what we are trying to do, we are trying to add some kind of a value, or add a negative value such that that value get redeemed, so that the less significant variables automatically removed from the model. So that is what we are calling as a regularization. You are regularizing the betas in such a way that a less significant variables automatically throw away from the model. When I say throw away from the model, means it is not getting any importance. If it is not getting any importance, what does that mean? It's anyway the model is not the variable is not contributing to the model. So that it automatically, we are removing the variables. That removal of variables, it's automatically reducing the variance in the data.
High significance is highly correlated with target.
That is what it means, right? And high significance is nothing but high driving. Not correlated. Correlation is something you are talking about linear relationship. I'm saying that a relationship, I'm not worrying about what type of relationship it has. Does that make sense? What do you mean understanding of regularization? Now, how can we do this process? That is the place. There are different techniques we have it. One is ridge regression. One is a lasso regression. One is a elastic net. So, of course, this regularization is not, of course, these are all our a linear regression perspective. If I change the betas, this is a linear regression perspective. These are the different type of linear regression models. But I'm talking about the regularization can be done for any type of model where you have a betas. Am I correct or not? If there is a beta, if there is an estimate, I can always regularize that model. So that is the regularization concepts. So both regularization and the cross validation and the tuning the parameters will help you to get a best model. I'm talking about irrespective of technique. right? So that means that whatever the process which I'm going to take now, I will include all these three concepts and I will try to explain that. Right? What are the three concepts? Grid sets. That is nothing but what? Tuning the hyperparameters. Okay? And cross validation and regularization. Of course, regularization is we don't use too much, but the cross validation and grid sets, which automatically we will use because that is part of what model building itself, it will take care. Right? So, of course, how to implement in Python, there is a grid set CV. Both of them can be implemented in using a single function, which is called grid set CV. Grid set CV will do both tuning the parameters and implementing the cross validation. So this is available in what? Scikit-learn. It's very easy for you. There is no need to really too much think about it. Right? So I think if this concept is understanding, the next set of techniques, of course, till now, whatever the techniques which we talked about, like linear regression, logistic regression, there we don't have any tuning parameters. I think the only tuning parameter is optimization perspective, the learning rate. You remember the learning rate concept I will explain today, what does that mean? But at least, the tuning, you don't have too much control, while you are building a linear regression, logistic regression with the help of tuning parameters. So that's the reason we always use those techniques as a traditional approach techniques. And when I say machine learning approach perspective, for a regression, classification, right, and segmentation, of course, forecasting is an application of regression now. Because you remember the last class I was talking about how can we extend the regression concept to solve forecasting problems. So regression problems, we have techniques like KNN, of course, decision trees, and random forest, bagging, and GBM, and AdaBoost, and KNN, ANN, and SVR. Of course, that is a extension of XGBM, XGBoost. So if someone want to know that, it is XGBoost is, the algorithm is same as GBM, but it comes with some additional features. Okay, so these are the techniques can help you to solve regression problems. Of course, the same things you have it, of course, a classification perspective. Support vector classifier, ANN classifier, KNN classifier, etc. And there is a naive-based classifier also we have it. And of course, in this case, K-means, K-medians, both are same. You remember the last class I was explaining that. There is another technique called DB-scan. Of course, there is another technique called spectral clustering, but out of that, these three are very popular. And forecasting, of course, any regression, if you convert this problem into regression, all the techniques like regression techniques, you can use it. But more interesting thing in this case is, of course, the ARIMA, what we have done in the last class, auto ARIMA, that is comes under what? We are identifying the best model based on supplying the tuning parameters, right? The ARIMA by changing the tuning parameters of PDQ. And of course, ANN is very popularly known for especially the tuning, the forecasting problem. More than that, we use a lot is a deep learning. When I say deep learning, there is a one popularly known technique called LSTM, long short-term memory models. So these are basically time series based models. Okay, so typically these are the different type of techniques which have a tuning parameters, which you can control with the help of the machine learning approach. Are you able to follow me? What I'm trying to say that? So as part of today's discussion, we will start with a decision trees. And when I say decision trees, this can be used for regression as well as classification. Of course, we also can be used as, this can be used as a objective segmentation. This can be used as an objective segmentation. If you understand this concept very well, and this is the exact concept we will use for an ensemble learning. Only thing is, the conceptual, you are extending the concept of this one to more number of trees. So this is the place, bagging, random forest, and GBM or AdaBoost and XGBoost. That is nothing but extreme gradient boost. So these are the things which we will talk about now. So before that, you want to take a break? Needed? Not needed. Perfect then. So let's take a 336, 350, we should be here. Mentioned that a linear regression, logistic regression, whatever we discussed, those also can be considered as a machine learning techniques, but they don't have much scope to improve the accuracy because the tuning parameters are only one parameter, which is a learning rate. So that's the reason we don't really consider them as a proper machine learning techniques. So generally the decision tree onwards, whatever we are going to learn, those will be more considered as a machine learning approach. As I said that for every technique, the approach again same. What is the difference you see? Only the difference in terms of algorithm, in terms of the conceptual understanding. But the implementation in Python, everything will be the same. Only thing changes the tuning parameters for each technique. The values for tuning parameter, those are the things will change. You know the metrics earlier, you know the cross validation, you know the validation, you know the how to check your model is good or not. All of these things are remain same. The data preparation remains same. Make sense? Okay. So now let's understand what is a decision trees. So the decision trees is something which comes in the form of shape of, let me check. Yeah, in the form of a tree shape where the decision will be taken at each node level. So let me explain that. So for example, I have some kind of a data, like, okay, customer data, you have it, customer ID, X1, X2, and X3, X4, X5. Suppose you have 5 variables and you also have Y variable. So assuming that this customer ID is unique ID and X1 is age, X2 is gender, X3 is a location and income and spend. Suppose this is this one. Your Y variable is a good customer or a bad customer, for example, a bad flag. Okay, so like this we have 1000 observations, we have it. Okay, and of course all the variables for this 10,000 10,000 customers, you also have 1000 1100 something like that. And what we need to predict, okay, if I give a 10,001 and if I want to know the predicted value of this based on the X values, this is what we call as a classification problem. Okay, so now the decision trees can be applied for both classification as well as a regression. So suppose if your Y is continuous and decision tree we call it as a regression trees. If Y is a categorical, it's a classification tree. So that means that what? Decision trees are two types. One is a regression trees, one is a classification trees. Or a decision trees, a regressor, classifier. Decision tree regressor, decision tree classifier. So that is what it means. Decision tree regressor and decision tree classifier. Is it clear? So now if I talk about decision trees and why is continuous and why is categorical, in this case, what type of classification? Is it a classification tree or not? We can build a classification tree on this data, right? Because here my y is what? Categorical, which is a 1, 0 variable. Okay, so now in this data, I want to build a classification tree. So since the data in this example, we build classification tree to predict a customer is bad or not, since my y is categorical variable. Correct or not? Okay. Now let's understand how the tree looks like. Okay, assuming that, okay, so first let me build the decision tree, and I will show you this is an example, and we will see underlying logic of this decision tree in a little later point of time. So first, assuming that this is the output you got it if I'm building a decision tree class. So what is the output? Something like this. Okay, my total number of customers is 10,000. Okay, and out of that, ones are 2,000 customers and zeros are 8,000 customers. Okay, so this is my original data. In this data, what happened? 8,000 customers are good customers, 2,000 customers are bad customers. So the total is 10,000 customers. How much percentage of bads? 20%. This is 80%. Correct? Okay. Now, assuming that, when I say the decision tree, I was referring that this is a node. I mean, we call it as a node. Each node level, it will get a split in such a way that one of the node will have a higher proportion of ones and one of the node will have a higher proportion of zeros compared to the node what we are having. So I mean to say that one node will have more than 20% of ones, one node will have more than 80% of zeros. That is the kind of a split you will get it. If a more percentage is high, can I say that split is more better? Why I will tell you. Okay, so now assuming that out of 4 variables, I got one variable called age. This age variable, if with a greater than 30, I'm seeing that maximum difference in terms of the proportions. Let me explain that. So if this is true condition and this is a false condition. So what is the true false? If it is greater than 30, if the condition is satisfied, I'm seeing that there are set of customers are like this. And if it is a false, and I'm seeing that there are set of customers are like this. What does that mean? With this condition satisfied, how many customers are there is? There are 4,000 customers are there. With this condition, how many customers will be there? 6,000 customers, because it's opposite condition only. And in this 4,000, ones are 1,400. Ones are 1,400. And in this case, zeros are how much? 2,600. And how many ones are there in this case? 600 ones, because anyway 2,000 out of 2,000, 1,400 are that side. That means zeros is how many? 5,400. So how much percentage you have it here? This by this, right? So the same percentage if I apply it here. So now what did you observe here? When I look at this one, these customers are 20% of ones. Overall, if I look at 20% of bad customers. But if I look at the split, this split is only 10% of customers are bad. And in this case, the split is 35% of customers are bad. So that means that if I look at the overall thing, if I have a high A's customers, there is a high possibility of the bad customers. Can I say that or not? That means low A's customers will be good customers because 90% of them are good. You agree with me or not? So that is the kind of a differentiation you are getting when you are splitting the data. But now the question is how the split has been chosen. That we will discuss in a while. Okay, why A's come as a first variable. That is the first thing. And how A split it at a 30. Why not 35? Why not 40? Why not 50? Those are some of the questions which we need to understand with respect to logic. But what I am trying to say is when the data is splitted at a node level, after the output of that splits should have a different proportion of ones and zeros compared to the previous node. If the difference is more, then it's a more good split. So when you say more difference, how can we say that, if the difference is more, how can we say that? I mean, what statistical metric I can use that can be used as one of the best relationship you have it? If the proportions are more, I'm saying that it's a good split. Correct? So instead of 20%, instead of 35%, suppose if I get another split is 45% of bads and here 92% of goods, that means that split is much better than the split, right? Now what I'm saying is how can we say statistically that split is better than this split? So this is the place you can think about a statistical test. What is the statistical test? So, okay, this is anyway this is my y variable, which is a categorical nature. And when I take the split as it is greater than 30 and age is less than 30, that means your y x variable, which is in a continuous nature, you are converted into categorical. That means that one categorical variable is there, other variable you converted into categorical. Now if I want to see the relationship between these two, which one, which statistical test you can use? Chi-square. Chi-square is a relationship between two categorical variable, right? Suppose if age is greater than 30, I got as a chi-square is, for example, 300. Okay, assuming that. If age is greater than 35, I'm getting as a 355. Which one is better? Which split is better? See, what I'm saying is, assuming that age is greater than 30, my chi-square value is 300. Suppose age is greater than 35 and you got the 355. And age is 40, greater than 40, I got 179. So which one is better out of three splits? Of course, 35 is the best split because where I'm getting the high chi-square, that means that high strong relationship. If the chi-square is high, it has a more strong relationship, right? Do you agree with me or not? So basically what I'm trying to say is the split will be finalized. What split it gives me highest chi-square value? What split which gives me highest chi-square? So out of A's, assuming that assuming that this is the highest you got it. So where I got A's is greater than 30, I got the highest chi-square value. So the A's at greater than 30 is the best split for getting a good proportion of ones and zeros. That is nothing but where I'm able to differentiate zeros and ones. Okay, for age also I can do like this. And similarly, I also have other variables. What are the other variables like gender? Okay, gender, anyway, you don't have option to split there, right? So only you have option is 0, 1. Okay, if the 0, 1, if I split gender equal to 0, gender equal to 1, and I got the chi-square value is 199. Because there you don't have option because only two categories you have, that is it has to split 0 and 1. But for example, if you have a location for a different combination of location, different combinations of locations, I can get the high chi-square value. So best thing is, okay, a location equal to Bangalore or Chennai. So if I take this as a split and I got the chi-square is 499, which is the best compared to other combinations. Sorry, 299 for example, not 399. So out of, age perspective, this is the best split. Gender perspective, this is the best split. And location perspective, this is the best split. Out of all these things, which one having a high chi-square? A's, and that's the reason that will be chosen as a splitting criteria. Are you able to follow me? How the split has been chosen? Okay, so we can talk about, there are other metrics like we discussed about chi-square, but there are some other metrics like, metrics for splitting criteria. One is chi-square. There is another metrics like Gini. There is another metric like entropy. There is another metric like information value. These are metrics for a classification trees. For a regression trees, the splitting criteria will be done is ANOVA, right? So that's how the metrics will be identified. So we'll discuss about one by one later, but at this point of time, at least you should understand how the split has been taken place. Does it make sense? Okay, again, once this is split is happened, and the next split is, of course, this 4,000 observation will be considered as a separate group. It's an independent group. This 6,000 will be considered as a separate independent group. Now again, it will look for what is the best split for these 4,000 customers. And what is the best split for the 6,000 customers. So this can be a different group and this can be a different group. So there is no relationship. Okay, suppose here I got as a gender as, okay, gender equal to male, and I got the split. What is the split I got it? Okay, this is the split I got it. And what is the percentage of observations? Okay. Okay, so gender with the male and gender with the female. Okay, so gender with the male. So out of 4,000 observations, male customers are there, 2,500 customers. And of course, and in this case, how many customers are there? 1,500 female customers are there. And out of these male customers, 2,500 customers, there are 1,000 customers are, or maybe 1,200 customers are ones. And how many customers are this one? 1,300 customers. And of course, here also 1,300 customers. And 200 customers are this one. And if I look at the bad percentage and good percentage, you can see that 87% of customers are bad customers or good customers, only 13% of bad customers. And here I got what is the other variable we have in that? Okay, location. Okay, so in this case, I got income as a variable. If income is greater than 3 lakhs. And of course, we have the split, you got it like this, and the split you got it like this. Out of the 6,000 customers, only 2,000 customers are with the greater than 3 lakhs income. And 4,000 customers are less than 3 lakh income. So out of 2,000, there are only 50 customers are bad customers, and 1,950 customers are good customers. And in this case, how many customers are bad customers? 550 customers are bad customers, and 3,450 customers are good customers. Does that make sense? So that means why you got a different variables over here? Because this is considered as a separate group. For these 4,000 customers, which split gives me highest chi-square value. Okay. For these 6,000 customers, which split gives me highest chi-square value. So that's how in the income is giving a highest chi-square value here, and gender is giving me highest chi-square value here. Sometimes it can be same also, it doesn't matter. But what I'm saying is there is a possibility of getting a two different splits, a two different distinct variables and distinct splits also you can get it. Okay, now this is not this is splitted further. This is also splitted further. Okay, here I got as income as a greater than 5 lakhs. Okay, with this income is greater than 5 lakhs, I'm seeing that okay, and if I look at this one, this 1500 customers with a greater than 5 lakhs, only 150 customers are there, and this is 1350 customers are there, and out of this 150 customers, only 0 customers are bad customers, and all customers are good customers. So that means that what 150 customers are good customers. And what about this? And all 200 customers are bad customers, and 1150 customers are good customers. This is the split you got it. And here I got as further split I got as gender or maybe location, for example. Okay, location equal to, for example, north. Okay, so location north, of course region you have it. So north, if I split versus north versus other regions, okay, this is the split you got it. And out of these 4,000 customers, north customers are 1,200 customers. Okay, and south and other than north, how many customers are there? 2,800 customers are there. And out of these 550 customers, only maybe 450 customers are bad customers, or maybe 500 customers are bad customers, and 700 customers are good customers. And in this case, how much? 50 customers are bad customers, and 2750 customers are good customers. Okay, so this is the, for example, while you are building a model, this is the place it stopped it, for example. Okay, so what I'm saying is the initial split you got as here, here the split is happened like this, and here the split is happened like this, and here the split is happened like this. Here the split is happened like this. Here the split is happened like this. Guys, you need to understand one thing here. I'm saying that this is the output you got it from the model. I mean, you run the decision tree and you got the output like this. Okay, this is not my own numbers. This is the output of your system, assuming that. Okay, so now let's understand what is this output tells me that, and how this output helped me to solve my business problem. What is my business problem? Predicting customer is good or bad. That is my ultimate goal of my output, right? So now tell me, okay, so when you are talking about a terminology, this is what we call it as a classification tree. Okay, and this is what we call it as a root node. This is what we called as a all are child nodes. Okay, and these are we called as the final nodes which we called as a leaf nodes. Okay, so that means that whatever final nodes which we called as a leaf nodes. How many leaf nodes you have it? 1, 2, and 3, 4, and 5, 6. Okay, don't forget these things. These are also final nodes, right? Here it stopped it. Correct? Are you able to follow me? Don't think that these are my final nodes. Wherever it stopped it, that is my final node. Okay. So, and assuming that this is my final node, and of course, Okay, people may have questions why Chandra is doing like this. We should use shortcuts of Excel. I'm not that much familiar, so probably I'm using like this. Okay, cool. So now let's understand this output. So when we are doing this output, let's take the output of final nodes. That is nothing but leaf nodes. Okay, 1, 2, 3, 4, 5, 6. So total 6 nodes. That means that total number of observations in each node, how many? So first node is 2500 observations. My second node is 150 observations. My third node is 1350 observations. My fourth node is 2000 observations. My fifth node is 1200 observations. My sixth node is how much? 2800 observations. Correct or not? Yeah. Cool. And out of that, how many ones and how many zeros? Okay, ones is 1200 here, and here 0, here 200, here 50, here 500, and how many of them remaining? Total, how many? This one 50, right? This one. Yeah. So now zeros means how much? Total minus ones approximately. And the percentage, I mean the P is nothing but what? Probability of y equal to 1, right? So what is the probability here? 1200 by 2500. So this is my probability. I mean, this is what the probability is, whatever I got is 0 probability and 1 probability. Correct? Now, if I look at this one, which segments or which groups are high risky segments, or which groups are low risky segments? You can say that this segment, the segment 1 and the segments 5, can I say that high risky segments? And this is a medium risky segment. And can I say that these are 3 low risk segments? Okay, so can I say that? So can I use this output as a segment output, a segmentation output? This is what we call as objective segmentation. So am I doing anything here? I'm not doing anything. Okay, which customers belongs to high risk, which customers belongs to low risk? I did not say anything, right? What I'm doing based on the output, okay, these are my characteristics of this segment is high risk segment. This set of customers are belongs to high risk. This set of customers are medium risk. This set of customers are low risk. Based on what? Based on what? Based on the probability value what you are getting by each segment. So now this is the output, you got it. Okay. Now can I say these are my probabilities? So can I say that if customer is coming from coming for a particular customer, I mean, if these customers are belongs to node 1, I can say that the probability of customer become bad is 48%. So this is my p-value. You know, this is the exact output you will get it. If I do a logistic regression, what is the output you will get it? There also you will get the p-value, right? This one. Now once I get the p-value, how can we choose my best cutoff? Either you can use AUC, ROC curve, or you can also look at, you know, by looking at this itself, you know, if it's greater than, I mean, my overall average is 20%, about 20%, I can take a bad, and less than 20%, I can take a good, or maybe business perspective, I can take cutoff is, okay, greater than 0.4 and above, I will consider as a bad customers. And less than 0.1, I'm calling as a good customers. In that case, which customers are good or which customers are bad? This, I mean, segment 1 and segment 5 is a bad customers. The rest are all good customers. So that's how you can think about it as a cutoff. Does that make sense? Okay, now how to use this output for predicting a new customer is a good or bad? Because there you will get a mathematical equation. Here, do we have a mathematical equation? No, right? Then how can we predict it? So this is the place you need to understand what is the rule of this segment. What is the rule of segment? If customer is greater than age is 30, greater than 30, and gender equal to male, and that is belongs to segment 1, right? If a customer age is greater than 30 and gender is male, and this is the, that means a customer and a high age customers with the males, there is a high possibility of bad customers. Can I say that? And what is the rule for segment 2? What is the rule for segment 2? That means, of course, greater than age is 30, that is fine. Gender is male. So gender is male or female? Yes, gender is female. Okay, not equal to male. What does that mean? It can be anything, right? Because which we don't know. Okay, and what is that? Income greater than 5 lakhs. So that is what the output it tells me that. Okay, if any customer is not, is the age is greater than 30 and is not a male and greater than 5 lakh income, then it's a good customers. That means they never had any bad customers, the bad experience with them. That means if someone is coming like that, and we can straight away give them a loan. Males are bad. Right? So that's what the model is saying. I'm not saying. Okay, what about the third rule? What is the third rule? Again, the concept is similar. Again, here is same. Only difference is less than equal to 5 lakhs. Of course, these guys also still less risky, but less than 5 lakhs is something, and I'm saying the little risk is there. If it's greater than 5 lakhs, there is no risk. Am I correct or not? And what about this, guys? Age is less than or equal to 30. No. Age is less than or equal to 30 and income is greater than 3 lakhs. Then that customers are, with very good customers. Of course, 3% usually bad customers. And what about this, guys? If customer age is less than or equal to 30 and income is less than or equal to 3 lakhs and location is north, then that customer again high risk customer. Okay, don't feel that I'm differentiating north versus south or something. Okay, just for the model input perspective, I'm explaining that. Okay, so then what is this one? If customer age is less than or equal to 30 and income is less than or equal to 3 lakhs and location is does not equal to north. So even other regions, if customers with less income also, they are good customers. That's what it tells me. So now, if I give a new data, like for example, a new customer's information, I have it. Okay, a customer ID. Okay, 1001, 10,002, 10,003. Okay, there are 3 customers which I want to predict. Age is 50 and income is 5 lakhs and location is south and gender is male. Okay, age is 28 and 2.5 lakhs and north and female and 35 and 3 lakhs or maybe 3.1 lakhs, and the north and male. So what is your prediction? Prediction means, suppose if customer is a good or bad, that's what we need to predict. But before that, we should have two things. What is the cutoff? And what is the rules? I think you should have, I mean, cutoff, assuming that I'm taking the cutoff is 0.4. So greater than 0.4, I'm calling as a bad customer. Less than 0.4, I'm calling as a good customer. The P, I'm talking about a P cutoff. Okay, now first of all, what is the P value for this? First of all, what is the node and what is the P value? Which node is belongs to? Or which segment is belongs to? Okay, 50 is A's. So that means where they are either this one or this one. Because these three, right? These three are possible for greater than 30 is A's. And income is 5 lakhs. So that means that income is less than equal to 5 lakhs. Okay, so gender equal to male. So gender equal to male means these two, this is the only thing happened, right? Because end of the day greater than 30 and gender equal to male. So which node is belongs to? 1. What is the P value? 0.48. And what is the prediction? Good. Very bad customer. Poor old man. So you understand or not how you are predicting it? Okay, now let's talk about what about this one. So less than equal to 30 is, that means these three. And what is the next thing you need to look at? Income. Is the income is what? 2.5 lakhs. That means these two. And location is north. So that means that this one. So segment 5 and 0.42. And again, bad customer. Little less risk. Okay, what about this one? 35 A's. That means that these three. And what about gender? Gender is male. That means that this one again. So again, node 1. And what is the bad? 0.48 and bad customer. Unfortunately, all are bad customers. So I'm rejecting the loans. Now you're clear what is the decision tree, how the decision tree output will be considered as a segmentation output, and how the output will be considered as a classification purpose. Do you agree with me or not?
Can you move to a class segmentation? Segment it into various variables.
That's what I told you, right? The first thing which I was referring, that objective segmentation. Objective segmentation is nothing but what? Based on the probability value, you can say that which segments are high risk, which segments are low risk, which segment. That's what the green and red and all of these things are, I was differentiating, right? So these itself considered as a segments, and these segment is differentiating with the other segment in terms of the proportion of bats, the riskiness. Any questions, guys? So now you are clear with what is my decision tree, what is my output of decision tree, how to use the output for a prediction purpose, how to use the output for segmentation purpose. Perfect, guys. So now I was referring that there are a couple of things. One is how the splitting criteria happened. I think you are clear now how the splitting criteria is. Whichever split gives me highest chi-square, if I take chi-square as a splitting criteria metric. Okay, and you also understand, okay, how these stopped at this level, why it is not extended. Okay, so the extension is depending on how you are defining the stopping criteria. Okay, let me tell you what do you mean that stopping criteria. You understand splitting criteria? Now stopping criteria. So stopping criteria can be, you can define based on where you want to stop it. Okay, one way of stopping is number of levels. Number of levels means what? Okay, this is the first level of split. This is the second level of split. This is the third level of split. So that means level 1, level 2, level 3. How many levels in this? 3 levels. So that is the, I mean, suppose if I want to keep my criteria is 5 levels, probably you can stop at 5 levels. Or you can also consider number of nodes. Okay, I want to get number of nodes is 10. Then probably if as soon as you reach 10 nodes, it will get stopped. Okay, that can be one thing. The other thing is number of features. What is the number of features? The number of variables will be used as part of the decision tree. For example, if I use 5 variables, suppose if I keep 5, as soon as 5 variables got used, it will stop it. Does that make sense? Or level of split significance. So that means if I give a significance level is 95%. So you know that the chi-square value will get it. Based on the chi-square value, you can also calculate the p-value. If the p-value is low, then that splitting is more significant split. Okay, if I keep 95% significance, until it reaches 95% of significance, only it will split it. If the significance level is more than 95%, or the 96, 97, sorry, less than 95% significance, then probably it will get stopped. If the p-value is less than 0.05, then it will split further. If the splitting criteria is greater than 0.05, it will stop it. That is another way of stopping it. And the other way of stopping it is minimum number of observations to split further. Min-obs to split further. So what does that mean? Okay, if I want to split further, I should have a minimum number of observations is something 100. Suppose if I keep criteria is 100, so what does it mean? If the number of observation is less than 100, it will not split further. If it's greater than 100, then only it will consider for splitting further. You understand what I'm saying? Suppose if my data is, for example, if I keep 150 or 200 as a splitting criteria, it will make sure that, okay, is the data having less than 200 or greater than 200 in this node? If it's greater than 200, then only it can be considered for whether split can happen or not. Okay, so that is the minimum number of observations to split. And min-obs in the node. What is min-obs in the node? Okay, if I keep min-obs in the node is 200 observations, what does it mean? When you are splitting, the split can happen one observation. Suppose you have 2800 observations, for example. 2800 observation is what you can do. You are splitting further. That means when you are doing the split, one split with the 5 observation, one split with the 2795 observation. That's also possible, right? I'm asking that when you are splitting, each node, the final node should have minimum number of observation is 200. So that means that when it's splitting further, it will look at least 200 observation in the node. That's what we look at. Does that make sense? So like this, there are different type of split, stopping criteria we have it. Different stopping criteria you have it to stop my to control my decision tree. So indirectly what I'm saying is, if I change these values, I will get a different decision trees or not. Okay, instead of taking a number of levels is 3, if I take 4, will I get a different model or not? That's possible. So can I say that these stopping criteria can be considered as a tuning parameters? That's all. These are all our tuning parameters for decision trees. So indirectly I'm saying that what are the values of these tuning parameters which gives me a best accurate decision tree. So that is my objective of when I'm building the model. Do you agree with me? Any questions on this? So that is the stopping criteria. So suppose if I mention the stopping criteria like this, and that will build the decision tree by satisfying those conditions. Are you able to follow me or not? Any questions? Perfect. So now I was referring that, I was explaining that the different metrics, the stopping, splitting criteria. What are the splitting criteria which I was discussed? Of course, chi-square, I already mentioned that. How chi-square will be calculated. Correct? And now let's understand the Gini and entropy and information value. Information gain, we call it as. So let me explain that. So the information gain or entropy, these are two metrics. Again, it will tells me that how pure your node is. When I say pure node, what does that mean? A node is pure. What does that mean? A pure node is nothing but if a majority of observations are, all the observations are either zeros or ones, then we call it as a pure node. So in this case, which node is more purer? Second node is 100% pure node, right? In this case, all the customers are good customers. And in this case also, again, this is also very pure node. And this is also pure node. Why? Majority of customers are either zeros or ones. Do you agree with me? So now you understand what is the purity of node. The purity of node is when I look at the node, maximum customers are belongs to the same category. Then you have the purity is more. Do you agree with me? Okay, now tell me how this purity, if a node is purer, what does it mean? I can say that the customers are good customers or bad customers based on the purity. Am I correct or not? If my node is more purer, the decision making will be easy. Yes or no? So that is what exactly we are trying to do that. So now let's understand. So at this point of time, this is probability for ones, right? This is a probability for zeros. Okay, when I take P and Q, okay. Okay, so when I'm taking the purity of node, this is something like that you will calculate. So this is what we call it as Gini. The Gini is nothing but 1 minus P square minus Q squared. So what is a Gini? So like in this case, what is my Gini value? 1 minus this is square minus this square. So what is my Gini value in this case? 0.32. So now what is the Gini value in this case? Okay, what did you observe in this case? If Gini is low, can I say that that node is more purer? Suppose if you look at this one, 90% of customers are good customers, only 10% of customers are bad customers. The Gini value how much? 0.18. In this case, 65%, 35%. Is that a more purer? No, right? The purity is relatively lower than this node. So that's the reason the Gini will be high. You cannot really differentiate zeros and ones here. So that is what the Gini is. So Gini is low, the node is more purer. Okay. So how this will be helpful as a splitting criteria. So, and this is the place at a level. So right now you calculate the Gini at a node level. So from the root node, this is got split into two nodes. Now each node you got the Gini value. At a level, at this level, what is the Gini value you got it? So that is the place, it's a weighted average of, you know, in this case, what is the percentage of observations are split it into one group one and split it into group two, 40% and 60%. So 0.4 times of the Gini value of this one plus 0.6 times of the Gini value of this one. And if I calculate, look this, what is my Gini? You got it? So at level 1, what is my Gini? 0.29. So how much improvement you got it from the root node to level 1? So 0.32 to 0.29. That's means 0.03. Correct. At least 3%. 0.03 is the net improvement you got it. So what I'm trying to say is, if I use what cutoff gives me highest improvement, what cutoff gives me highest improvement, and that will be a best split. Does that make sense? Suppose in the chi-square perspective, what did we do? Whichever split gives me high chi-square value, that will be a best split. If I use Gini as a metric, whichever split gives me high improvement in the Gini. High improvement in the Gini means, you know, low, you should have at that level, you should have a low Gini. Correct? That will be considered as a best split. And similarly, entropy also the same thing. Entropy is basically the entropy formula like this: P times log of P So this is the formula for entropy, guys. What is the entropy in this case? What is the entropy value in this case? Okay, this is my P value multiplied with log of P comma base 2, because you know the base 2, plus Q times of log of Q base 2. It's not a percentage number. 1 second. Okay, the formula is minus is the formula. Okay, guys. So this is the formula for entropy. So again, the entropy also, if you look at, if the entropy is, you know, high value, then that's not a good node. And of course, the same thing I can also calculate for what? For what? And I can calculate here also, okay, entropy for here also, and I can calculate, okay, minus this time into log of this comma 2 minus, you know, this into log of, excellent. Okay, what about this one? Of course, you can also do in this manner also. Okay, for the time being, this time moving this one. What is my entropy value? Okay, again, this is the Gini at this level. And what about entropy at this level? 0.4 times of this value minus and sorry plus and 0.6 times of this. So now what is the improvement, net improvement you see from 0.72 to 0.65. Again, whichever best cutoff gives me highest improvement in terms of my entropy, and that is my best split. So the difference between the root node level and after splitting that, that is what we call as a information gain. So the information gain is how much? Information gain at a level. So what is the information gain? You got it? 0.72 minus 0.65 65502. So of course, whatever the value you got it, that is what the information gain means. What happened? So this is the information gain, you got it. So which split gives you highest information gain? That will be your best split. Okay. So now you understand, different type of splitting criteria can be chosen. Either chi-square can be chosen, or a Gini can be chosen, or entropy can be chosen. You can choose any of these three can be chosen as a best splitting criteria. Do you agree with me? Any questions on this? No questions? No, each algorithm will be used as different. So there are very popularly known algorithm called COT algorithm. The COT algorithm will use either Gini or entropy. Okay, so the Chade algorithm is another algorithm which you'll use, and a splitting criteria is chi-square. Right? So like this, there are different algorithms are different based on the splitting criteria is one of the key thing. And COT is always do the binary split, and the Chade can do a multi-split. And COT can be used for regression as well as a classification. Of course, regression you will use a classification. You will use splitting criteria as a Gini or entropy. For a regression splitting criteria. What is that? ANOVA. Okay. So like this, different algorithms we have it. So COT is nothing but the full name is classification and regression trees. And the Chade is chi-square automatic interaction detection tree. So what is interaction detections? So the interaction is nothing but how the variables are interacting together. So for example, if I look at that, and gender, after the gender income is coming, so that means these two are interrelated. Suppose instead of gender you got some other variable, then the income may not come here because that interaction may not be good with that variable. So what I'm saying is the next split will also depend on my previous split. So that is the interaction which I was talking about. So that interactions will be captured based on chi-square. That is the reason this particular algorithm which is called as chi-square automatic interaction detection trees. Do you agree with me? Okay, so this is the classification tree. Now if I give the same thing as a regression tree, what is the change you see? Splitting criteria, that time what happened is, for example, okay, let me give you that. Okay, this is the thing I got as a volume. Volume means number of items you purchased. Okay, so 300, 400, 500, whatever the values you have it. And now suppose if this is the case, the x variables are more or less similar, and what is my y variable is, okay, my total number of observations are how many? 10,000, right? My root node level 10,000 observations are there. Now in this case, the average volume is how much? For example, assuming that 500, average volume is 500. That means a customer purchased 500 items on an average. Okay, now I want to predict which customer is going to buy how many items. Okay, so then the splitting criteria, suppose now what is the split? For example, a gender equal to female. And then how many customers we have? Gender equal to female, probably okay, n equal to, for example, 3,500 customers are there. And in this case, how many customers are there? 6,500 customers are there. And in this case, what is my average volume is, okay, assuming that girls are purchasing more number of items, then the volume will be how much? Instead of 500, probably 1,200. Okay, and this average volume how much? Okay, just for make him happy, so we'll give it as 100. Right? So are you able to follow me till now? So how the splitting happened? So this is my numerical value. My y variable is numerical variable. If I'm splitting the data into category, my x variable is category. If I want to see the comparison between the groups, comparing the average between the groups, how can we do that? Where there is a relationship between your categorical and numerical, how will you do that? ANOVA, right? You guys forgot. ANOVA will be helpful for finding the relationship between one categorical and one numerical. I think n number of times I told you. So what can you say? That whichever split will give me the highest F value, that will be chosen as the best. Okay, okay, these 3,000 customers, 3,500 customers further splitted. Okay, income is greater than 4 lakhs. Okay, so these customers, of course, I have n equal to, of course, for example, 1,200 customers are there. And these customers, around how many customers you have? N equal to, for example, 2,300, right? And the average volume they purchased is 2,100, and these guys average volume is probably 600, suppose. Assume that. And these guys also further split it into, okay, location, okay, north, maybe south, and you got 2 groups, and here you got 2 groups. And what is the n? N is, for example, south only 1,500 customers are there, and here n is 5,000 customers are there. And these guys average volume, if I look at, these guys spend maybe 20 items, and these guys average volume is maybe 180. One is high, one is low. Correct? So, and further it can split further also. So like this, you will get, for example, assuming that these are the 4 nodes you got as a final nodes. Now output is how? Okay, this is first node, this is second node, this is third node, this is the 4th node. And what is the n? N is 1,200, 2,300, and 1,500, and 5,000. And what is the average volume? 2,100, 600, and 20, and 180. And what is the rules? if customer is gender is female and income is greater than 4 lakhs, and gender is female and income is less than or equal to 4 lakhs, and if gender is gender equal to male, okay, other than male, and location equal to south, and if gender equal to male and location other than south, correct? So if any customer gives, if I want to predict the value of how many items they are going to purchase, will you able to predict or not? Okay, for my new customer, okay, 10,001, and the age is 30, and gender equal to male, and location equal to north, and income equal to 5 lakhs, and of course 10,002, 35 is gender equal to female, south location, 10 lakhs is income. What is the predicted value? And gender equal to male and location equal to north. So that means that this is the, so fourth node is the prediction. And what is the average volume? 180. And what about this guys? 2100. How? The male, gender is female and income is greater than 5 lakhs. So that is the, sorry, greater than 4 lakhs. So this is the segment, the first segment. So what is the first segment average volume? 2100. So that's how I can predict the value. Once I predict the value, I can look at the accuracies and all of these things with the help of metrics. Am I correct or not? So this is what we call it as a regression trees. So the regression tree, classification tree, both are same. Even regression tree, your predicted value is, you will get the predicted value like this. In a classification tree, you can predict the output as a probability, then you can choose the cutoff and you can get that. Or if you don't choose the cutoff, by default, it will give you the cutoff is 0.5. If you want to predict the output category, you can get the output as a category, but with the by default cutoff is 0.5. But that is not always true, because I told you, if you have the data, so if the data is balanced data, what do you mean balanced data? 50% of ones, 50% of zeros, then you can take a cutoff is 0.5. Okay, if the data imbalanced data, that means one is less than 50%. I mean, one is less than other one, not similar. And then we call it as a number of ones are different from, I mean, is not equal to number of zeros. Then we call it as a imbalanced data. So for example, 20% is ones, 80% is zeros, for example. It's imbalanced data. Then the cutoff you need to come up with. You need to come up with the cutoff based on the what? You remember high accuracy, high sensitivity, high specificity, high, and I think all we discussed in the logistic regression case. Remember or not? The concept is same. Okay, so any questions till now? The regression is clear and classification is clear with the help of decision trees. I think you listened entire Ramayana and now you're asking who is the husband of Sita.
There's a choice.
What is the choice here? I explicitly, very clearly I mentioned that y is a continuous variable, then it's a regression tree. If y is a categorical variable, it's a classification tree. If it's a classification problem, classification tree, you have to use it. Am I correct or not? That is the first point I started with. Where did I start with? If it is a regression tree and a classification tree, see, Y is continuous and regression trees, and this also we call it the decision tree regressor, and Y is categorical classification tree, and decision tree classifier we call it as any questions on this? So you want to take 5 minutes break? Okay, let's take a quick 5 minutes break. Then we will implement both of them in Python. Okay. What happened? What's happened? You guys are feel heavy. Okay, guys, one option we have. Okay, so let's do one thing. I mean, I'm giving you two options to you. One option is, so we need to finish this part and the ensemble learning part. So is it okay for you guys to come either one of the Saturday, Sunday, either you can prefer either Saturday or Sunday. And so, I mean, it's a 2 to 5 basically. I mean, just like today. Okay, the reason I'm saying that is I want to finish these topics together, because otherwise what happened is there will be a discontinuity. And the next week onwards, Sunit will take the sessions. Okay, I want to finish this concept before I leave. Basically, I'm traveling. So the next few set of sessions will be taken by Sunit. Okay, so what I want is, before I do that, I want to make sure that these topics will be finished, so that there is no, I mean, the next topics are completely independent of these topics. There is no issue as such. But if I stop it here, probably you will have some kind of a challenge to connect the dots. What do you think? Which day you want to come? Tomorrow? No, my suggestion is tomorrow. The reason is you will have a Sunday break, so that Monday onwards the sessions will again start. So my suggestion is, let's finish tomorrow, and then the remaining part we will take from the Monday, right? So probably, you know, what happened is, once I complete this part, I think the ensemble learning is not much problem, because end of the day, this is the core concept of random forest, bagging and boosting and all of these things. So if you know these concepts very well, that the implementation of these things in Python is hardly matters. There is not much challenge in the Python perspective. The conceptual perspective only is the key thing, right? So in that case, let's stop today. Then come tomorrow at 2 o'clock. You know, I have a class in the morning. That's the reason now, the challenge, right? Let's have a session at 2 o'clock as it is like today, right? Good. Any challenges? Perfect, guys. You guys are rocking. Thank you then. Then let's meet tomorrow at 2.